generate around 80 zettabytes of data today, which is almost 40x increase in the last decade alone. The need for data scientists and machine learning engineers is skyrocketing. Experts estimate that this data will grow even more to 200 zettabytes by 2025. Have you ever wondered how this data is stored? Can this data fit into a single server? Most of the software engineers talks about partitioning the data to solve for the limitations that is posted by a single server. Hello and welcome to my new video on sharding. I'm Mohit Yadav, and in this video I'll try to explain you the basics of sharding, and also I'll give you some of the strategies that is associated with sharding. When it comes to managing large data sets, we really have three choices. The first choice is vertical scaling, or functional scaling, or horizontal scaling. The vertical scaling is increasing the capacity of server on which data is stored. If the capacity of the server was earlier, let's say 512 GB, as the storage needs increase, we might want to migrate it to a server that can hold up to 1 TB of data. As you might have already guessed, this is not a very scalable approach. Hence, let's look at the second approach, which is functional scaling. In functional scaling, we try to split the data logically. I'll give you an example. Let's say you are running an e-commerce website, and initially there were not many users, so you are storing everything in a single data node. All the tables which are keeping information about the users, their purchase history, and inventory was also stored in a single database in a single node. Now, as users are increasing, as you're getting more users, their purchases will increase, the number of users will increase, the inventory will also increase if you are onboarding new sellers. So each of these tables will independently increase. One way to scale your application is to break it into smaller pieces. One application will manage the users, the other will manage purchases, the other will manage the inventory. You might also have different microservices managing each database and sharing the data to other services via API. This logical split is almost always implemented at the application layer, meaning that there will be a piece of code which will be responsible for routing the read and write request to the designated database or the designated microservices as well. This is what we call as functional scaling. Horizontal scaling is what is called as sharding. In simple words, sharding is a way to split and store a single logical database or dataset over multiple servers called data node. This is in contrast to functional scaling, where we were splitting the data logically. We are segregating users, orders, purchase history, inventory into different datasets or microservices. Here, I will be splitting a homogeneous set of data, homogeneous table. For example, I will be splitting a user table or an order table. This is what we call as the sharding, right? And because of this very reason, because it is a uniform way of splitting data, we split the data based on one column of a particular table. Because of this reason, it can be automated and it can be implemented at an application layer or at a database level as well. Now let's try and understand how database decides where one row will go or where it will not go, which data node a particular record needs to be stored. To understand that, let's see how a request propagates through the entire system. All the requests will start from what we call as a client. A client can be a mobile device, a web browser, or living room device as well, right? From the client, the request will go to the load balancer. I'm skipping the DNS resolution step. So it will go to the load balancer. Load balancer will then transfer this request to one of the many available application server, right? This is application server. This will again be an application server and an application server. The application server will then push this message. Let's say it's a write request. So it will try to write to a database. Currently, since we just have one data node, all the requests will go to this particular data node called data node 0. Now, as the volume increases, what we want to do, we want to split the data to two different data nodes, right? So let's add two more servers. So this is server 0, this becomes server 1, and this is server 2, right? Now, let's dig deeper into one table. Let's say we want to know about the order table. In order table, we are maintaining order ID, we are maintaining user ID, we are also maintaining the item ID. Let's say for simplicity, these are the only three columns, right? Now, for user ID 1 purchased item 1, user ID 1 purchased item 2, user ID 2 purchased item 1, user ID 3 also purchased item 2. Let's say these are the only 4 records. Now, to split the data, what we need to do, earlier all the requests that were coming were going to one single data node that was available. But now, based on the value of any one of the column, we can decide algorithmically where every record is going to be stored. So let's try to insert each record, and the algorithm that we are following for simplicity's sake is the modulo algorithm, which is that I will take modulo of column value, whatever column we decide. Let's say I decide user ID, and I take a modulo with the number of available server. How many number of available servers are there? 3. So modulo 3 will come. And this column that we have selected as a sharding key is user ID. Shard key is basically the column on which I'm determining how distribution of the keys will happen, right? So I'll take the first example. I take user ID. The first row will basically go to shard 1. So I enter order ID 1 here. The order ID 2, user ID is 1. Again, modulo 3 if I take, it is 1. So it will come here. The third one, the order ID 3, 2 modulo 3 is 2. So order ID 3 will come here. For 4, 3 modulo 3 is 0. So order number 4 will come here. That is how the distribution in an algorithmic fashion takes place. This can also be done in a slightly different manner, wherein we don't do things like this. We don't have an algorithm to determine where each row is going. But what we do is we create a namespace. We create one more table. We create one extra server here. This is called as a namespace server. What this does is it creates a mapping of every primary key. So for example, order ID 1 is stored in server ID 0. Order ID 2 is stored in server 1, and something like that. And whenever you want to retrieve this value, you first query the namespace server, find out which server ID is storing that particular record, and then query on that particular node. So there is one extra step that comes in this kind of a fashion.